Imagine blowing up a balloon. It stretches and grows, getting bigger with every breath you add. The surface becomes taut, and you can almost feel the pressure building inside. This simple act is a perfect way to picture what's happening deep beneath our feet. Right now, far below the surface of the Pacific Northwest, volcanoes are swelling up in a similar way, slowly, but steadily. These mountains, which seem so solid and unchanging, are actually in motion, growing, shifting and evolving over time. But instead of air, it's molten rock, magma, pushing its way upward, causing these massive mountains to expand from within. The magma collects in chambers, building up pressure and making the ground above bulge ever so slightly. This swelling is a sign that the Earth is alive and always changing. Our planet is dynamic, with forces constantly at work beneath the surface, shaping the land in ways we can barely imagine. Scientists have detected this subtle growth in several Washington volcanoes using incredibly precise instruments like GPS receivers and tilt meters, which can measure even the tiniest movements of the ground. The changes are tiny, just inches or even fractions of an inch over years, but they reveal powerful forces at work. These small shifts are clues that help scientists understand what's happening deep underground. It's not something to fear, but an incredible chance to learn about our planet. By studying these changes, we gain insight into the natural processes that have shaped Earth for millions of years. This swelling is happening both on land, like at Mount Rainier, where hikers and scientists alike keep a watchful eye on the mountain's subtle changes, and far beneath the Pacific Ocean, where underwater volcanoes quietly reshape the seafloor, hidden from view, but no less powerful. Each volcano has its own rhythm. Some are quiet for centuries, others are more active, with eruptions and steam vents that remind us of their presence. No two volcanoes are exactly alike, and each tells a unique story. The latest excitement is about Axial Seamount, an underwater volcano showing signs of activity. Scientists are closely monitoring it, eager to learn what its movements might reveal about the future. Let's dive into the science behind these swelling giants and see how understanding them helps keep us safe. By studying rock samples, monitoring data, and building models, researchers can predict eruptions and protect nearby communities. By the end, you'll see how science helps us become better neighbors to these amazing, fiery mountains, appreciating their beauty, respecting their power, and learning how to live safely alongside them. So, what's making volcanoes swell? It's a question that's fascinated scientists and curious minds for centuries. The answer lies deep beneath our feet, in a world we rarely see but often feel the effects of. Volcanoes are more than just mountains. They're windows into the Earth's fiery heart. Magma, a super-hot, gooey mix of melted rock, minerals, and gases, lurks below the surface. It's the lifeblood of volcanoes, constantly churning and shifting, waiting for its chance to break free. This molten material is what eventually erupts as lava, reshaping landscapes and creating new land. Deep underground, intense heat and pressure melt rock into magma, which rises because it's lighter than the solid rock above. The Earth's crust acts like a lid, trapping the magma until enough pressure builds up. This process can take years, decades, or even centuries. Magma collects in chambers beneath volcanoes, building pressure as more accumulates. These chambers can be massive, stretching for miles, and they act as reservoirs for the molten rock. The more magma that enters, the greater the pressure inside. This pressure pushes the ground upward, causing the swelling scientists measure. The land above can bulge and crack, sometimes shifting several feet over time. These changes are subtle at first, but they're crucial warning signs. The process is slow, like inflating a tough tire, one tiny pump at a time. Each addition of magma is almost imperceptible, but over months or years the effect becomes dramatic. It's a natural buildup of energy, waiting for release. Magma is packed with dissolved gases like a shaken soda can. These gases are trapped under immense pressure, making the magma even more volatile. When the pressure is finally released, the results can be explosive. As it rises, pressure drops and bubbles form, making the magma even more explosive. The escaping gases help drive the magma upward, sometimes blasting it out in spectacular eruptions. This is the first chapter in a volcano's eruption story. Before any eruption, there's a long buildup, a hidden drama unfolding beneath the surface, setting the stage for what's to come. By tracking swelling and gas release, scientists can estimate how close a volcano is to erupting. They use satellites, GPS, and gas sensors to monitor every movement and chemical change, piecing together clues from the Earth itself. It's a powerful example of how science helps us read the Earth's signals. These tools allow us to predict eruptions more accurately, giving people time to prepare and stay safe. Understanding magma's journey is key to predicting eruptions. By studying what's cooking down below, we unlock the secrets of volcanoes and learn how to live alongside these incredible forces of nature. Nearly 300 miles off the Pacific Northwest coast lies Axial Seamount, a volcano hidden a mile beneath the ocean. It sits on the Juan de Fuca Ridge, where tectonic plates pull apart and magma rises to create new seafloor. Since its last eruption in 2015, Axial's summit has been swelling, like a giant balloon inflating. Pressure sensors show the ground has risen about 10 feet, signaling the magma chamber is filling up. Recently, daily earthquakes jumped from hundreds to over 1,000, a classic sign of an impending eruption. Scientists now predict Axial will erupt again by the end of 2025, a rare chance to test their forecasting skills. It's like having a front-row seat to one of Earth's most powerful events. Hearing volcano eruption might sound scary, but Axial Seamount's deep-sea location makes it harmless to people and ships. The mile-deep ocean acts as a giant lid, containing the eruption on the seafloor. Unlike shallow eruptions like Tonga's in 2022, Axial's depth prevents explosive blasts or tsunamis. Instead, magma oozes out, forming pillow lavas, rounded black shapes that instantly cool in the icy water. The 2015 eruption created a massive new lava flow, reshaping the ocean floor. These eruptions transform the deep-sea environment, creating habitats for strange creatures like tube worms and crabs. For them, an eruption is a feast, not a disaster. It's a reminder that destruction for some is new life for others in the deep ocean. Axial's eruptions are a hidden spectacle far from human danger. Axial Seamount is a natural laboratory for scientists. Its frequent, predictable eruptions allow close study without risk to people. A 300-mile fiber optic cable connects Axial to shore, powering a network of sensors and cameras. This setup streams real-time data to universities, letting scientists monitor swelling, earthquakes, and chemical changes 24/7. Forecasting Axial's eruptions has already advanced volcano science. Each eruption cycle teaches researchers more about the warning signs before an eruption. Lessons from Axial help scientists predict eruptions at more dangerous volcanoes on land. By understanding the links between swelling, quakes, and eruptions here, we can improve safety everywhere. The deep-sea rumblings of Axial are making the world safer. While Axial prepares for its next eruption, it's not the only volcano in Washington that scientists are watching closely. The state is home to a dramatic chain of volcanoes, each with its own unique story and potential hazards. Washington's Cascade Range volcanoes, like Mount St. Helens, Mount Rainier, and Mount Baker, are also under constant surveillance by geologists and emergency planners. These land-based giants are close to millions of people, making their activity much more significant. Their looming presence shapes the landscape and the lives of those who live nearby. Mount St. Helens, famous for its catastrophic 1980 eruption that reshaped the mountain and sent ash across the country, is slowly recharging with magma, a process that can take decades or even centuries. For now, it remains mostly quiet, though not showing signs of imminent eruption. Mount Rainier, towering over Seattle and visible for miles, is considered especially dangerous due to its massive glaciers and proximity to densely populated cities and towns. The main threat from these volcanoes isn't just lava flows, but lahars, fast-moving destructive mudflows triggered by melting snow and ice during eruptions or even heavy rain. These can travel far down river valleys, threatening communities miles away. To keep people safe, scientists use GPS, satellites, and sensitive seismometers to monitor these volcanoes for swelling, tiny earthquakes, and other warning signs. This constant monitoring acts as an early warning system, giving communities precious time to prepare if danger arises. While no eruptions are expected soon, the potential for sudden change is always present in volcanic regions. Vigilance and preparedness ensure we'll have warning if one of these sleeping giants wakes up. The Cascade volcanoes demand respect and attention, reminding us of the powerful forces beneath our feet. Thanks to science and constant vigilance, we're better prepared for whatever these mighty volcanoes may bring in the future. The danger a volcano poses depends on its location. Deep-sea eruptions like Axial's are contained by ocean pressure, posing no threat to people. Land volcanoes like those in the Cascades can erupt directly into the atmosphere, creating hazards for nearby communities. Ashfall from a land eruption can travel hundreds of miles, collapsing roofs, disrupting travel, and causing health problems. Pyroclastic flows, fast, hot avalanches of ash and rock, and lahars are unique dangers of land volcanoes. Lahars, triggered by melting snow and volcanic debris, can bury towns in minutes. These hazards don't exist with deep-sea eruptions. That's why monitoring land volcanoes is so critical. Their beauty is matched by their potential for destruction. Location truly shapes the risks and the science. Science is our best tool for living safely with volcanoes. By studying safe sites like Axial, scientists learn to read the warning signs: swelling, earthquakes, and gas changes. This knowledge powers early warning systems for cascade volcanoes, giving communities time to prepare. Education is key. Scientists help people understand hazards, make emergency plans, and know what to do if an eruption happens. Preparedness turns fear into action. Volcanoes build new land, enrich soils, and support unique life, even as they pose risks. Science lets us appreciate their power and stay safe. By watching and learning, we can live wisely alongside these volcanic giants.